Okay, in today's video, our goal is that the student will be able to factor quadratic equations in order to solve for the zeros. So I need you to think back to yesterday. Yesterday, we looked at quadratic graphs. You built quadratic graphs. And after you built the quadratic graphs, you named the zeros. And the zeros, remember, are also called solutions or roots. There's a bunch of names for zeros. So the zeros, though, were the x-intercepts. And usually there were two, okay? So we are still finding the x-intercepts. But I'm going to show you how to find the x-intercepts by factoring so that you don't have to use the graph. There's a lot of methods for finding the x-intercepts of a quadratic. Today we're just going to look at how to do it when you factor. Okay, so here's your steps. First, we're going to set the equation equal to 0. Then we're going to factor out the greatest common factor. If there is one, there isn't always a greatest common factor. Then, if you have a trinomial, so you have 3 pieces, you're going to factor into 2 binomials. And then we're going to solve each factor. Okay, so example number 1, 9y squared plus 3y. Step 1 says to factor out or set the equation equal to 0. That's good. Already done. Step 2, so we're going to look at step 2, factor out a GCF. So the greatest common factor between my 2 terms, 9 and 3. The biggest number that divides into 9 and 3 is 3. Now, the greatest common factor really is the biggest thing that both of those pieces share. So we know they both share a 3, but they also both share a y. So I'm going to take my greatest common factor and write it first. And then inside of parentheses, I'm going to write what I have left over. So 9 divided by 3 is 3. If I have y squared, but I take the 1 on the outside, I just have 1y left with it. 3 divided by 3 is 1. And the y I took on the outside. That's still equal to 0, okay? All right, now step 3, if you have a trinomial, factor into 2 binomials. I don't have a trinomial anymore. I have a monomial, 1 part, and I have a binomial, 2 terms. I don't have a trinomial, so I can skip step 3. Step 4 says we need to solve each factor. So in step 4, I'm going to solve for y twice, because I'm going to take my factors and split them apart. So my first factor is 3y, make that equal 0. My second factor is 3y plus 1, make that equal to 0. So because it's equal to 0, I can solve each of them for 0. So if I look at this first one, to get y by itself, we're going to divide by 3. 0 divided by 3 is 0, y equals 0. All right, in the next one, we need to add 1. 3y equals 0 plus 1 is 1, divided by 3, y equals 1/3. So if you graphed 9y squared plus 3y, you put it on a graph like we did yesterday, you would see that it crosses 0 pretty easy. But this 1/3 wouldn't be very clear. You would know it crossed somewhere between 0 and 1, but you wouldn't know the exact fraction unless you did it algebraically. So that's why it's important that we understand how to do it on a graph so that we know the visual aspect and where it comes from. But we also need to understand how to do it with algebra so that in case we have weird non-whole numbers, we can get an accurate answer, okay? All right, question number 2. First step is set the equation equal to 0. Well, my equation already says equal to 0, so I'm fine. Step 2, factor out a greatest common factor. Well, first let's look at all 3 of our terms. So the first term is 1x squared. The second term is negative 2x, and the third term is negative 15. If I have a greatest common factor, it needs to be something that all 3 of those terms share. The only thing that all 3 of those terms share is 1. And if your greatest common factor is 1, you don't need to do anything with it, because if you divide them all by 1, nothing will change. So we get to skip step 2 also. All right, step 3, if you have a trinomial. Yes, I have a trinomial because I have 3 terms. 1, 2, 3. If you have a trinomial, factor it into 2 binomials. So we are going to start with that step. So start with step 3. and we're going to factor this trinomial. I like to factor using the multiply add chart, okay? That's how I do it. If you don't remember how to factor at the end of this video, you still don't understand the factoring piece of it, then I've put a second video in today's page that just says some more in-depth factoring notes, okay? So feel free to watch that one if you need some more help factoring. I also need to remember that there's like 20,000 different methods people use to teach factoring. So I tried to ask your older teachers what they used, and it seemed like to me, I just asked them an email. So it seemed like to me that they did the same method, but it may not be exactly the same. So keep that in mind. Watch this video. If you're still having trouble with factoring, watch the next video also, okay? But we're going to do step 3, which is to factor into two binomials. So I need two numbers that will multiply. A times C, 1 times negative 15 is negative 15. And they need to add to negative 2. Okay, well, I know if I use negative 5 and positive 3, those multiply to negative 15. And they add to negative 2, so those are right. So I build two binomials, but the x is first, minus 5 in one, plus 3 in the other. Because my leading coefficient, my a value is 1, I don't have to do anything else with factoring. Set those equal to 0. Okay, so step 3 said to factor into two binomials. I've done that. Step 4 says to solve. So in this one, we only had to do step 3 and step 4. So in order to solve, we're going to separate our two pieces. So one binomial, x minus 5 equals to 0. The other is x plus 3 equals to 0. Solve for x, so add 5. X equals 5 minus 3. X equals negative 3. So if you were to put this quadratic on a graph, you would see that the parabola crossed the x-axis at 5 and negative 3. So remember, we're still finding those pieces on the graph. It just looks different today, okay? Example 3. Step 1 says factor out, or set the equation equal to 0. Done. Step 2, factor out the greatest common factor. I have 5, 34, and 24. There are no numbers except for positive 1 that goes into 5, 34, and 24, so I can skip that step. Step 3, if you have a trinomial, yes, I have a trinomial, factor into two binomials. So we're going to go to step 3, we're going to factor. Okay, so I need two numbers that multiply a times c, 5 times 24. Hang on, I don't want to make a mistake. 120. Two numbers that multiply to 120 and add to b, 34. Okay, so factors of 120. I know 10 and 12. That's not going to add to 34. 2 and 60. That's not going to add to 34. 3 and 40. Nope. 4 and 30. There you go. So 4 plus 30 is 34. So 4 and 30 are the ones that work. So I'm going to build my two binomials, starting with x. I put 4 in one, and I put 30 in the other. Now, because your a value is not 1, you have to divide to undo the multiplication you did before. If your fractions simplify, simplify them. If they don't simplify, kick back the bottom. So if I have 4 over 5, that doesn't simplify. I'm going to kick back the 5. So this is really 5x plus 4. And x plus 30 divided by 5 is 6. Equals 0. All right, step 4, solve. So 5x plus 4 equals 0. X plus 6 equals 0. Solve for x, so minus 4. 5x equals negative 4, divide by 5. X equals, oh, I ran out of room. X equals negative 4 over 5. The second answer, x plus 6 equals 0, minus 6, x equals negative 6. So your two solutions, the two x-intercepts that you would find on the graph, are where x equals negative 4/5 and x equals negative 6. Okay? All right. Example 4. Sorry. Yawn. Okay, example 4. Set the equation equal to 0. Done. Factor out the greatest common factor. Well, my coefficients right now are 1, negative 8, and 15. Those don't have anything in common except for 1, and if it's only 1, you get to skip it. All right, step 3. If you have a trinomial, factor it into two binomials. Yes, I have a trinomial, so I'm going to factor in step 3. All right, so I'm going to make two numbers that multiply to a times c. 1 times 15 is 15. We're going to add to b, negative 8. Okay, I know that negative 3 times negative 5 is positive 15 because the negative times negative is positive. I also know that negative 3 plus negative 5 is negative 8. So those are my two numbers. So build two binomials. Start with x. Put minus 3 in one, minus 5 in the other, equals to 0. Now, in the last one, I had to divide by a. That's only because a was a number other than 1. Here, our a value is 1, so I'm finished factoring. And step 4 is to solve. So x minus 3 equals 0. X minus 5 equals 0. Solve for x. Add 3. X equals 3. Add 5. X equals 5. Okay? Next one. Example 5. Step 1, solve for 0. Done. Step 2, find a greatest common factor. 3, 11, and 4. Nothing in common. Make sure you look at the odd answers today because there are some more examples of when there is a greatest common factor to pull out of the trinomial. So don't ignore the odd answers that I did in your assignment, okay? Step 3, factor. So step 3, we're going to factor. All right, so I need two numbers that multiply to a times c. 3 times negative 4, negative 12. And then I need to add to b, negative 11. Okay, so I'm going to use negative 12 times positive 1 multiplies to negative 12. And negative 12 plus 1 is negative 11. So that works. So build two sets of parentheses. Start with the letter. Then your factors, minus 12 plus 1. Then divide by a. Okay? So negative 12 divided by 3 is negative 4. So s minus 4. This one does not simplify. 1 over 3 doesn't simplify, so kick the 3 back in front. So 3s plus 1. All s equals 0. Now that I have factored, step 4 is to solve. Okay, so s minus 4 equals 0. And 3s plus 1 equals 0. Add 4. S equals 4. Minus 1. 3s equals negative 1. Divide by 3. S equals negative 1 over 3. So this, if you graphed 3s squared minus 11s minus 4, you would notice that that graph touches the x-axis at 4 and negative 1/3. Okay? All right, 6 and 7 are kind of weird because we're going to go backwards. So you can't use the same steps because we are not factoring, we are going backwards. So I gave you the zeros here. I'm giving you the x-intercepts. You need to give me the equation. Okay, so if I gave you the x-intercepts and I'm telling you that x equals to negative 2 and x equals to 6 are the two answers you would have gotten, right? So I need to undo or go backwards from what I just did before. So first, write each factor has x equals. Okay, we've done that. Step 2, solve, or I guess rearrange is a better, we're not really solving, but rearrange the equation, rearrange the equation so that you have something that equals 0, okay? So if I want it to equal 0, I need to add 2 to both sides. So then I have x plus 2 equals negative 2 plus 2 cancels, so 0. Okay, good, so I've done that. Now the next one, in order to get rid of the 6, I need to subtract it. So x minus 6 equals 0. Okay, good. Step 3, I'm going to build the two binomials. So take your x plus 2 and put it beside your x minus 6. Okay, step 4, I need to multiply so that I'll have standard form, because standard form is ax squared plus bx plus c. So I need to take these two sets of parentheses and I need to multiply them so it looks like that instead. So x times x, x squared. X times negative 6, negative 6x. 2 times x is 2x. And 2 times negative 6 is negative 12. Now we're going to combine our like terms. So x squared is negative 6x plus 2x is negative 4. So my standard form equation is y equals, or f of x equals, x squared minus 4x minus 12. Okay, when you put your answers into Canvas today, pay real close attention to how I want you to input that one, okay? All right, number 7. First, write each factor as x equals, or each 0, really. That should say write each 0. Okay, so this one says roots, but remember roots and zeros are the same thing. So step 1, write each root as x equals. So x equals negative 5, x equals 1/2. Step 2, rearrange so that the equation equals 0. So in order to get rid of minus 5, the opposite would be to add 5. So x plus 5 equals 0. Now this one's kind of weird with the fraction. In order to move the fraction, we're going to do it in 2 parts. First, multiply by 2. So 2x equals 1. Now minus the 1. So 2x minus 1 equals 0. Okay? Step 3, build the two binomials. So x plus 5, and that's kind of messy. And 2x minus 1. Okay, step 4, multiply. X times 2x, 2x squared. X times negative 1, negative 1x. 5 times 2x, 10x. 5 times negative 1, negative 5. Combine your like terms. Negative 1 plus 10 is positive 9. Okay, that's it. So again, if you're still having trouble with the actual factoring piece and remembering how to factor, watch the second video today, okay? Otherwise, start your equation and you're good.